Hello, Dr. Konopka, and here's my final report on chess and artificial intelligence and how they intersect. So, what I wanted to research was essentially how do these chess engines think, and how do these AIs think in general? And they're kind of the same thing, chess AI and AI in general. Um, and how can we implement how they think to make ourselves better at chess? What can we learn from them? And what can we learn from their thought process? And the top chess players in the world do this. They do statistical analysis, and but I'll get on to that later. First, what I researched was in various articles and scholarly articles was how do computers think, and how does AI think, and how specifically do these chess AI computers think? And so I went on kind of a historical evolution of these, different AIs and different computer engines, and starting back with the most rudimentary forms are the brute force method and the evaluate and store method. And they started in about the 80s, 70s, but brute force was the one that finally became more popular, and more chess engines used brute force. And the essential way that it thinks and processes and works is it looks at a board position, and then it looks at every single possible next move, and every single possible opposing move, and every single possible piece that can move, and it grows exponentially, all the different variables, till it finds the most optimal move, and then that's the one it recommends. And you can see the problem here, the exponential kind of growth, and that requires an exponential amount of processing power. So that is a little bit of a problem if you want to scale up to a perfectly accurate chess engine. But nonetheless, it worked, and it became popular. And the 1997 Deep Blue engine created by IBM used brute force, and it beat Garry Kasparov, the then world chess champion. And so essentially, there's some, conspiracy theories around this, because Kasparov accused IBM of planting a Russian guard in his waiting area to listen in and find out, and his moves or his strategies for breaking the machine. And IBM refuses this, but they also dismantled Deep Blue immediately after winning and swore their programmers to secrecy, so a little suspicious. But anyways, that's brute force method, and it obviously works. And evaluate and store, that method essentially looks at a given board position, and then is programmed the next optimal move. And this is not as strong because it doesn't really learn. It's kind of dependent on the human putting in the best move, and it will take a while to program every move, maybe forever, given various board positions. And so those are the methods that were used in the 1990s, essentially. But by the 2000s, the next kind of more popular method, or new method, of computer AI was the neural net. And neural network, neural net, same thing. But essentially, the way a neural net works, the way a neural network works is by having inputs, this kind of hidden area, hidden valley, whatever you like to call it, and then the output area. And so essentially, the inputs are put in, and then through a network of weights and biases, it comes out a value. And hopefully that value at the end will recommend the correct chess move. And it's essentially just a long math problem that will dictate the best chess move that should be played. And the idea of a neural net is it's trying to simulate a human brain and get some more intelligence and creativity inside the computing process, because the way the neurons work in our brain is one neuron stimulates another neuron, stimulates another, and thought isn't centralized in one area, and it's human thought isn't linear like the brute method thought. This is more complex, and it's a web, and it's a network, just like our brain. And essentially, they fine-tune the weights and biases by knowing the correct output for a given situation, putting the input in, and then waiting until and adjusting the weights and biases until it's more accurate, so that they can apply this neural network with the correct weights and biases to another similar problem. And then the hope is that it'll be able to learn and adapt in the new problem that it faces and give a correct response. And the results are very promising for neural nets. They're in fact the chess engines that we use today, and they're the smartest. And they're very impressive. And then the next way computers think for AI and chess in general is, I'll get to this in a minute, it's deep learning or machine learning, whichever way you like to call it. Deep learning is a subset of machine learning, but anyways, it's essentially an algorithm that processes data, makes looks for differences within groups of data, and then applies those differences to new data to try and learn about the new and make inferences and decisions off the old averages. And it's very effective, and that's just a brief overview of how it works. But another way it works too is a decision tree. Like, if yes, go this way; if no, go this way; if yes in this certain protocol, go this way. And it's called a decision tree. And the larger decision trees are called decision forests, which I kind of like because it gives some life to the whole computing process. And those are essentially the main ways that computers think. Neural nets and machine learning are the most advanced, and Google created a chess engine called AlphaZero, which crushed the last Stockfish 8 computer engine. Stockfish 8 had a ELO rating of 3,400, and Magnus Carlsen has one around 2,800. And the AlphaZero neural net crushed Stockfish 8 with 28 wins to 0, I believe, and 62 ties or draws, I believe, something around there, but never lost a game with it. And the way it works is just a neural net. It didn't learn from any grandmaster kind of games to get like a rudimentary set of kind of protocols. It learned by playing against itself, and it's rather astounding that after 4 hours of playing against itself, that it was able to beat that Stockfish 8. Yeah, it's very incredible. And so now that we know how computers think, we can look and try and apply that to how we can get better at playing chess. And the top players use statistical analysis and positional analysis with AI to create or find the best sequence of moves in a given position. So what that means is you program the AI to do a certain opening, say Queen's Gambit, here, and then here, and then you see after there what it does, and then it plays thousands of iterations of the same, move, or it doesn't have to be an opening, it can be a position, and, it does thousands of iterations of it to find the optimal kind of next steps that, the grandmasters and people who compete can use in their games. And it's rather powerful. Anand Vishwani, I don't know his last name, but he was the reigning chess champion until Magnus Carlsen beat him, and he uses this method, and statistical and positional analysis are very powerful, but they aren't the only method that humans use to learn from AI. Gary Kasparov had a observation on this. He said that what we can learn from AI is that they never get frightened, they never have anxiety, they're never, excited to move a piece when they see a move. They think rationally about what the next move is, stay level-headed, and never let their emotions get ahead of them. And that's something that every chess player has to get better at and can learn from machines. The second way we can learn from these machines are also bots. We can play against bots and try and hopefully their superior movements and responses will be stored into our subconscious, and we can apply them later. But we can also just learn them as a benchmark or play against them as a benchmark and learn do our openings against a bot and then see how they respond. And based off how they respond, if someone does that opening to us in a game, we can remember back to how the bots responded. And using AI to learn from them and apply their thought process and methodologies is valuable. And one other way that you can, that what we learn from AI is that essentially every position in chess is defendable. If you're in a bad position, a lot of chess players can either get flustered, they give up, they don't know what to do next. But if you play it right and keep thinking ahead, you can win, you can come back, and you can make slow, gradual gains. That's how the AI works, and that's what we can learn from them. But Gary Kasparov, in one of the articles, I believe it was the human versus machine thinking in the story of chess, he described how that humans have a special skill that machines do not, and that's positional and strategic thinking. Some of the newer neural nets and deep machine learning learned kind of positional valuations of pieces, but they still don't totally have to the human level strategic thinking. And that's an edge and distinction that we can use to our advantage in a game of chess, against a machine or against a robot. And another way that I learned about how AI thinks and what we can learn from them is through the aesthetics paper, a scholarly article. It was talking about how computers and AI can look at a board position just like a human can and interpret beauty in it, because some of the high-level players can see a position and recognize it as beautiful, and look at the sequencing that happens in the game and look at it as an art. And some AI have been able to correctly recognize that within a board position. And that is very interesting because that seems to involve the realm of creativity. So maybe these bots are gaining some insight to creativity that one day they can apply fully to the game of chess and to the world around us. And that's my presentation. Thank you, and I appreciate this this last semester playing chess with the chess club and being able to go and to the Queen City Chess Classic. And thank you. Have a good